Hello and welcome back. We are closing in on the finish of the VPC section of this AWS Essentials course, but now we're going to circle back around to availability zones, which I did touch upon in the infrastructure lesson, but this time I'm going to talk about how they're used specifically within the VPC and what they mean for VPC subnets and other aspects of the VPC. I'm going to touch on how availability zones work within a VPC, high availability and fault tolerance, and then at the very end, we're going to talk about Project Omega requirements and make sure that we have done everything that we need to do for the Omega project. So let's jump right in, and we're going to take a closer look at the definition of availability zones. Now, I know I already talked about this, but we're going to go through this one more time because going over these things again and again will be very helpful and important. So any AWS resource that you launch like EC2 or RDS must be placed in a VPC subnet. Any given subnet must be located in an availability zone. You can and should utilize multiple availability zones to create redundancy in your architecture. This is what allows for high availability and fault-tolerant systems. These are two terms you are going to hear endlessly when you're working with Amazon Web Services. For a bit of a more defined definition, we can look to AWS, and they state that when you create a VPC, it spans all of the availability zone in that region. After creating a VPC, you can add one or more subnets in each availability zone. Each subnet must reside entirely within one availability zone and cannot span zones. Availability zones are distinct locations that are engineered to be isolated from failure in other availability zones. So if you remember back to the infrastructure lesson, when I had the availability zones laid out and they were geographically separated from each other. By launching instances in separate availability zones, you can protect your application from failures in a single region. So this is very important, and this is one of the core benefits of using cloud services in AWS in general. What I mean by this exactly is if we look at our VPC diagram, we have two availability zones in this diagram, although we actually have four availability zones for this VPC to use. What we want to try to do when we build applications and systems in AWS is to have resources or duplicate resources span availability zones. We have resources in one availability zone and we want duplicates in the other. So let's say, for example, we have a website which we're hosting in AWS. And for that, we have a primary web server. Backing that up, we have a primary RDS database that is providing content and information to the web page. So if a customer accesses our website, their information comes in through the internet gateway, through the route table to this particular web server. That web server may then, through the other route table, through the non-internet connected route table, will access this subnet, grab information, populate the website, and send the information back to the customer. Now, in another availability zone, we want to have a backup web server and a failover RDS database. This is important to have set up in case this availability zone goes down. So if there's an earthquake, a fire, a power outage, or for some reason the data center in this availability zone fails or these become inactive, well, then we can just simply switch over to our backup instance and our backup database, and therefore our downtime will be either low or non-existent, and our customers won't have any service interruption while trying to use and access our website. So traditionally, if you have a data center or if you're hosting a web server in your home or in an office and that were to go down, you may not have a backup in a different geographic location. But here, these two availability zones may be separated by 100 miles, 50 miles, 200 miles, 500 miles, and something disastrous can happen in one availability zone and you can have backups in another availability zone that can quickly be provisioned and launched, or can already be provisioned and launched and just waiting for something to happen here, and then you can fail over to the services that you have in a different availability zone. So that's the importance of availability zones in building highly available and fault-tolerant architecture. So again, one of the few things we just want to focus on is high availability. Creating your architecture in such a way that your system is always available or has the least amount of downtime as possible. What high ability sounds like is this, and this is something that somebody would say. I can always access my data in the cloud. It is always available. It is highly available. My website never crashes and is always available to my customers. So when somebody is properly using high availability architecture, this is something that they would say. For fault tolerant, again, that is the ability of your system to withstand failures in one or more of its components and still remain available. So what fault tolerant sounds like is somebody saying, one of my web servers failed, but my backup server immediately took over. Or if something in my system fails, it can repair itself. And we're going to get to that in later sections. But it is very important to understand the concepts of high availability and fault tolerance within cloud architecture so that as you move forward and start to use AWS, you can use best practices to make sure that your systems are highly available and fault tolerant. So again, summing up availability zones, they are distinct locations that are engineered to be isolated from failures in other availability zones. And that is the main takeaway that you need to know about availability zones. Okay, so since we've now come to the end of this section, let's take a look at Project Omega infrastructure requirements and see if we have met everything that we need to do. So for section 3, we needed proper traffic routing into and out of our AWS virtual private cloud. Okay, so first, one internet gateway attached to the VPC. Well, let's take a look at internet gateways. We do have one internet gateway, and it is attached to our VPC. One route table with a route to the internet. Let's take a look at our route tables. One route table, it should be this one right here, with a route to the internet. One route table without a route to the internet. If I click on my other route table, there is no internet gateway attached, so there is no route to the internet. So great, that satisfies that condition. Two public subnets, each in a separate availability zone, and two private subnets, each in a separate availability zone. Again, we meet this condition if we look at our subnets. We have two public and two private subnets, and we know that because the two public subnets have a route table that has an internet gateway attached, and our two private subnets have a are associated with a route table that does not have an internet gateway attached. And if we scroll over and we look at availability zones, we see here that each one of them is in a separate availability zone. And again, that is to create highly available and fault-tolerant architecture. So, great. We have now finished this section in which we talk extensively about virtual private clouds. Now, there's also so much that I'm not able to get into in a shorter course which concentrates just on the essentials. But hopefully this gives you a very good overview of what a VPC is, what it's used for, how it works, and what its various components are in terms of the way that data flows in and out of VPCs and in and out of Amazon Web Services as a whole. So with that, let's go back to our main diagram, and we see here we have now conquered the VPC section of Project Omega, and next we're going to start to dive into specific AWS services starting with S3. So with that, we will complete this lesson and complete this section. Thank you for watching. You may now move on.